Alright, so for this part of the video, we are going to cover everything SQL or SQL related. So, as I mentioned in the Word document, and I'll mention it here as well, this project wasn't really supposed to be focused on, creating complex or be heavy on SQL queries. It's really that SQL or Ssms was supposed to be a bridge from getting our data to Power BI to where we could see and visualize our data. Because with the data we have here, in my opinion, you could do analysis on it, but the analysis that you can perform on it, it's not going to provide a whole bunch of insight. So that's why I don't have a lot of, queries that'll help explain why one player did good in the season and why one player did bad in the season. There's a lot more that goes into player performance than just numbers. Like some things you cannot really measure, like if a team had a coaching change, maybe a player performs better under a certain coach, or they perform better playing in different cleats. There's a lot of things that, when it comes to sports, are not really measurable, and it would be hard to quantify the effect that they have on a player performance or a team performance for a given season. So I'll go over the query, store procedures, and the jobs that I built out so far, and it'll take us into our last part, which is the Power BI segment. So the first thing I want to look at is I have a folder with all of the queries. So under the NFL project folder, you can see that I have a folder called SQL queries, and I have different folders within that SQL queries folder. And the main ones I want to focus on is this queries one here, the stored procedures, and that's really about it. So we'll take a look at this first one here. And some of these queries are not going to be mentioned in this video because we already covered them in the earlier part, like in SSIS, where we had to correct one of the rows in the team stats or fix one of the columns as well. But the ones that I do want to go over, and they follow a general concept, like this query here, it's going to be the same for kicking, punt, Russian, that should be Russian, and it should also be for defense as well. So we could open up one of these, and it's going to follow the same format for the other tables. And we have to change our database to the correct one. So now what this query is going to do is that, if you can remember, we had an issue with Pro Football Reference where in some of the tables, although a player played in a game, they did not have a position associated with them. So we were not able to create a composite key in the players list table and in the Pro Football Reference table regarding whichever table we were looking at. Let's say we were looking at passing. And then I'll show you a quick example as well. So if we select all from passing, you can see that Cam Newton plays quarterback in the NFL, but for some reason, when the data was pulled, and this is the same case on the Pro Football Reference site when you go to check it out, they leave some of the values for the position column blank, and I don't know why Pro Football Reference does that, and it's something that I don't think I could fix personally, because there's no way of determining, okay, we're looking at this player, what should his position be? Because if there's a player who does not have a position and that's his only record, then we would have no clue what position he plays. So I decided to leave it as that. But there's a workaround for this, and I'm going to show you how I did it here. So this is what our passing table looks like, and it does not connect to any of the tables, I believe, in our database. And we can take a look at the database schema one more time. So you can see here, this is our passing stats table, and the only thing it's connected to is this table called NFL years. It's still loading, but I know this table is the years table, as you can see here. That's the only table that this passing stats table connects to. We're not able to connect it to the teams table or the players list table up here because, like I said earlier, we were not able to create a composite key where we have the player name and their position. If we did have that information filled out on the Pro Football Reference site regarding passing stats, then we would be totally fine here, but we don't, and we had to create a solution, or I had to create a solution. So what I did was that I selected everything from both tables. We're going to select everything from the passing stats table and the players table just to make things a little bit easier. I'm not going to selectively choose columns. Might as well bring everything over. So once we do that, we're then going to create a new column called clean player name. And what this column will do is that from the player column in the passing stats table, it's going to remove any special symbols next to a player name. So Cam Newton in row 11, for instance, he has a asterisk and a plus sign next to his name. The asterisk, I believe, represents first team All Pro, and the plus sign represents the Pro Bowl, if the player made the Pro Bowl. I'm not too sure, but they mean what I said earlier, but it may be switched around if I'm incorrect. So we need to remove those symbols if we want to join the passing stats table to the players table. If we don't remove them, then we're going to get null values. And since we're performing a left outer join, we're returning all of the rows in the left table because I want to see all of the players in the passing stats, no matter if they have a match or not. Now, they should have a match because we set up a criteria in our Python script to scrape players from 2010 all the way up to 2021, so those players should be in there. But just in case, maybe there's a special character, which I didn't run into, that was not removed or not replaced correctly, and we get a null value. So this is why I have the left outer join and not an inner join. And doing these projects, I find myself doing a left outer join or outer join more often than an inner join. So that is how we join those two tables together, and we're going to join it on the player column in the passing stats, or the player column in the players table. And then since we cannot use aliases in SQL when we're specifying which columns we want to join two tables on, I had to use the raw function here. So when we run that, when we run this, you can see that this is what the passing stats table looks like now. Now, when we run our query, it's going to execute. Takes no less than 5 seconds. Still have the same information. Everything is now sorted by the player name. And you can see that we have joined those two columns successfully now. So we brought everything over from the passing stats, and then we're bringing information from the players table. So let's look at one example here. So we have AJ McCarron in row 2. So everything up to here is in the passing stats table. Everything after the player column on or after the player column here is from the players list table. So you can see we have AJ McCarron, we have his height, we have his weight, his birthday, information we did not have before in the passing stats table. although we might not use all of the information here, it's still useful to have, because the main thing or the purpose of this query was to get the player picture and the player profile name. So you can see we have our created column here called clean player name, and this is the created column. This is coming from the passing stats table. So as I mentioned earlier, it's going to remove those players with symbols next to their name. And we could look at a better example here where we have Aaron Rodgers, where he have an asterisk and a symbol and a plus sign next to his name. But when we come to the clean player name column, it's going to be the same exact, it's going to be his regular name. And you can see that there's a match between the passing stats table and the players list table. So this is exactly what we wanted. And now we have his player link and we have his player picture. So when we go to Power BI and we need to specify that the player picture column is a image URL, we could do that easily, and then Aaron Rodgers picture will show up. His player link, we can have a hyperlink. If you click on his name in Power BI, his player link will take you, or that when you click on his name, excuse me, that link will take you to Aaron Rodgers' page. And so should be no nulls here because I made sure I accounted for every symbol. And that's really it for that query. And as I mentioned earlier, the other queries are going to follow the same concept and format. So rushing, kicking, kick, punt, return, and the defensive stats are going to follow this same format. And that's how we get our tables to connect to the players list. So we had to do a bit of data manipulation just to get those two tables to connect. And then when we go into Power BI, we could easily run these queries using the get data or the SQL Server feature. Put that query in there and then we'll come out with the same results. Now, one thing I do have to watch out for, because we were not able to connect the tables directly, is that some players have the same names, and when those players have the same names, they have duplicated rows. So you'll have a row for, let's say, if someone else was named Aaron Rodgers in the league and they played the running back position, you would have Aaron Rodgers where his position is the quarterback, and you'll have all of his stats. But then you'll also have another row regarding Aaron Rodgers where his position is running back, but he still has all of the same passing stats that the original Aaron Rodgers had. So there was a way where I took care of this in Power BI where I just filter out what I did not need, and we'll see that later down on the road. But basically, this is what we did for a lot of our queries or a lot of our tables that were not connected to the players table. The next thing I want to go over is the stored procedures. And the stored procedures, as you could tell from the names of them, they're pretty self-explanatory. There are a few I want to go over, and we could start with the email ones. We could just look at one of the emails. So you can see what this stored procedure will do is that it's going to basically run a query, and then from that output from the query, it's going to send it to me as a CSV file, and I'll get it in as an email, and I'll show you what that email is. So this is looking at game results. So this is not really a good example because the 2020 season or the 2021 season hasn't started yet, but we could look at the transactions that happened today. Now, currently, since the database or the package to update the tables has not been ran yet, as well as the Python scripts to get the NFL transaction has not been executed yet, we don't have no new data for today. So we're going to return blank rows. But yesterday, when all of the scripts and packages were ran, I received an email from the database stating that there were new transactions or the output file. So we go to Gmail. So you can see the emails I get from the database. We have the injuries, we have the transactions, and then I also have one more job here that tells me which job has been ran for the day and whether it's been successful or not. I haven't ran into an issue where the job has failed yet, but it depends on if I have my computer on or not. If I don't have my computer on, then the job is not going to be ran until I turn it on, and then this email comes in a little bit later. But we can take a look at the transactions, and as I mentioned earlier, it's going to get sent every day, so nothing here for that date of transaction. I believe Saturday, August 28th, a bunch of preseason games were being played, so I don't really expect a lot from teams there. We can look at something a little bit earlier than that. So let's look at something from August 26th. So we click the email. We have our CSV file here. It's formatted properly and everything. We open it up and you can see all of the transactions that have occurred on the 26th. And that's exactly the date when that email was sent out. So 2 players were fined for wearing no mask. We had a player released, we had a player traded, waived, a couple players signed the contract. So this is what that stored procedure is going to do, and it's going to do the same thing for the game results and the injuries. So that's really it for these 3 here. The rest you can tell what they do by their names, but there are a couple more that I want to go over. And we could look at the games upcoming teams list home. So if we run this query, and let's exit out of the rest of these. If we run this query here, this is coming. So this is coming from the CBS Sports page, I believe. And the thing about them is that when they have the teams who are going to play against each other, they don't use a full team name. They'll give the team city name or a bit of an abbreviation of the team name. So that means that we have to try and find a way to connect it to our teams table. And this is just the beginning part of the query we built, which will later connect to another table in Power BI, because there was a way I had to find out on how to get those tables to connect. And we'll cover that. We'll definitely go over that in the Power BI section. But for right now, this is just the beginning stages of it. And I could go over it now. Basically, what I had to do in Power BI was just create a new column where I had to specify a column delimiter with a space on the teams table for the team name. So that will give us the city for the team name, and it would work for, I would say, 90% of the rows here, and then I would have to do a bit of editing on my own just to fix the ones like LA Chargers, LA Rams, like Giants and Jets. Those were the only ones I believe I had to fix, but other than that, we just did a comma delimiter based on the team column, and then we had the same amount of, or the same values pertaining to the teams based on this query here. But when we get to Power BI, you'll get a better understanding of what I did with this query here. Same thing for away. It's basically the same query, but it's looking at the away teams. This one here, transactions and injuries. Again, CBS Sports website does not use the full team name when it comes to stating which player got injured for a team. So I had to create another workaround. And the Spot Rack website does not use the full team name as well. They use the same abbreviation as CBS Sports. So to begin with, I noticed that I could easily join those 2 tables together, and then in Power BI, all I would have to do is just create a list or like have another table that connects those tables together, so where it'll eventually link up to the full team name. But this is better visualized than explained because it gets a little bit complicated, and the database diagram or the table diagram in Power BI is very complex because we've had so many tables. But as I mentioned earlier with the other stored procedure, this is just the beginning. So you can see that we're taking one from CBS Sports website, the team name, and the other one from Spot Rack. And I trimmed it because in Spot Rack, sometimes they have spaces, so we needed to remove those spaces. So you can see all of the team abbreviations we have here, and then this is going to be later used in Power BI in a way where we could connect it back to the teams table that we have. And that's really all for the stored procedures I wanted to go over. The last thing in this SQL part that I want to go over as well is the jobs that I created. So we could exit out all of this. So the first job I want to go over, and I mentioned it earlier in the video, or in one of the video parts, and in another and in the document, is that I created a job in SQL Server Agent where the updating NFL tables SSIS package will be ran through the SQL Server Agent. We have the job, and this job is going to be ran every day at 7:30 p.m. and you can see that it's going to reference our updating NFL tables package, so the data is going to come in consistently. And then we also have these steps on when to run it or how to run it, so you can see it's ran every day at 7:30, so it's important to have my computer on around those times. And that's basically it. It's just going to run that package and update the tables we have in our database, see what rows are not already in there, and then just put those rows in there. The next one that pertains to this project is called NFL emails, and we've seen those before. As I said, we have a stored procedure for it, but now we had to set up a job to have those emails get sent out to us daily. So you can see one for NFL transactions and one for NFL injuries. There's not one yet for game results because the 2021 season hasn't started yet, but when that one does start, or when it do start, I'm gonna be sure to make sure to update this. So you can see here, basically the same thing, exactly what we viewed before. And I did mention in a document that I could send this out to multiple emails, so it's not really an issue to send it to someone else if they want to look at it. And you see every day, you can see every day is going to be ran at 7:35 p.m. So right after the data has been updated. After that, the last one, or the last SQL Server Agent job that I want to go over, is just basically a maintenance plan, just backing up the database. Very helpful because you never know when the database will go down, and it's good to have backups just in case. I haven't ran into an issue where I needed the database backup, but I know from my time in school that those database backups were important, especially when you want someone else to look at the database and use it for educational purposes. So the database is going to be back up at the beginning of the month. I'm not sure the time, but we could check that right now at 11 a.m. So Monday every month. And I have the same backup with the stock project or the stock market project I did, and it's been working fine so far. But other than that, that's really it for the SQL part. Like I said earlier in the video and in the document as well, that I didn't go too crazy with the SQL queries because the data available to us is not really meant for analysis. It's just to look at historical performances. You can't really predict how a player is going to perform next season because there's so many things that can affect how a player plays. But we could finally move on to the last part, which is the Power BI section, and it's very important and crucial that in this section we have everything correct because this is the final product that we're going to try and push out or show to other people. So let's move on to the Power BI part.